All right, lecture 4B. So we want to talk about conditional operations, how we implement something like an if-then statement. Well, so remember I said that the reason we talk about coding instructions in machine code in binary is to help us understand what instructions can and cannot do. So here's a typical C statement. If x equals y, then do some stuff. And so to code this, we might say if x is not equal to y, let's do a goto and skip over all these things that we want to do if x is equal to y. So we could say if x equals y, do instructions 1, instructions 2, instructions 3, and so on. And then down here is instruction 4. So we might say if x is not equal to y, go to whatever label we had for instruction 4. But there's a problem with this. Remember, we have 16 bits within which to code an instruction. We need a few bits for opcode. We need a few bits for a destination address that we want to actually branch to. That does not leave us enough bits to even specify one file register, let alone two. Right? There's simply not enough space in these 16 bits for us to specify a file register or a pair of file registers, because we're going to need probably 8 bits to specify a location to branch to. We're going to need a few bits of opcode. We need 8 bits at least to specify a file register plus an access bit. So there's not enough space in this 16-bit word to code up what we would need to do to actually say, compare this file register to that file register, and then do something based on the comparison. So we don't do this. In the past, when we had to do something with a file register and we didn't have enough space to specify it, we used the W-reg. So this would be one option, is to say, okay, our conditional branches will check the W register and see if it's equal to say 0. But W register has already got a job. It's a general purpose register we use for moving literals into, for adding to other file registers, and so on. So we don't want to use the W register also to tell us when we should execute a conditional branch or not. So the PIC processor, and actually most other processors, use a totally different scheme. They use something called a status register. And the status register is just a plain old special function register. It's in that upper location of the file registers that we have in our PIC processor, and it's register FD8 hex, and it's called status. It's an 8-bit register. Well, it has a very special purpose inside the PIC processor. Most of the instructions that we perform will update information in this status register. For example, one bit of this register is called Z. So Z is a single bit, it's a 1 or a 0. So if the previous operation resulted in 0, then Z will be true. Else, Z will be false. So Z tells us if the last thing that we did ended up with a 0 or not. There's a bit called N, which says if the previous operation resulted in something less than 0, N equals true. If it was greater than or equal to 0, N equals false. That's the negative bit. This is the 0 bit. So when we do something like increment file register hex 20, the PIC processor's hardware, after we're done incrementing, doesn't matter where we store it, it looks at the new value. Okay, remember read, modify, write. Well, after it's modified this, after it's added 1 to it, it says, hey, is the result equal to 0? If it is, it will set the Z bit to true in the status register. If it's non-zero, it'll set Z to false. And then it says, is the thing that we just incremented now negative? If it is, it'll set the negative bit to true, otherwise the negative bit is set to false. And there's a handful of register bits inside the status register. There's an overflow bit, there's a few others. So if we want to know, did incrementing this register cause it to be equal to 0 or not, we can do the following. We can say increment the file register, right, at location 20, and then we can do what's called a conditional branch. So a conditional branch is another one of a set of control instructions, and we can say, for example, BZ branch if 0, and we put in an opcode, and we put in 8 bits of offset. So we can branch plus or minus about 100 instructions from our current location. And when this instruction executes, it will say, okay, check the 0 bit of the status register. If it's true, if 0 is true, go ahead and branch. Otherwise, don't branch, just go on to the next instruction. So what can we do with this? Suppose we have a file register that we call count. And let's say we just store that file register at location 20. So we'll have a count statement equal to hex 20. So count is a pseudonym for hex 20. So our comment here is decrement count. So we can say decrement file count. And it will go back into the file register because I didn't say comma 0. So this will take the contents of file register 20, subtract 1, and write it back. Now what we want to do is say if count is equal to 0, branch to stuff. So we know that when we decremented count, the 0 bit got set accordingly. If count was equal to 20 equal to 0 after we decremented, the z bit will be true. So to say if count is 0, branch to stuff, all we have to do is say branch if that z bit is true to stuff. Right? And if count is not equal to 0, this does not branch. And so otherwise, continue here. Okay, so let's rehash that. This decrements the file register called count, that's location 20, and it sets the 0 bit accordingly. This says if the 0 bit is true, branch to whatever the label stuff is, which is somewhere else in our program. If the 0 bit is false, this is basically a no op. It doesn't do anything, and we'll simply go on to whatever the next instruction is. So now we have a condition, right? We said count gets the value count minus 1, and then we said is count equal to 0. And if it is, then we come down here to whatever the code is that we called stuff, and if it's not, then we just come down to whatever this next set of code is after the branch statement. So this is the main way we're going to do conditions on the PIC processor, okay? And we can branch if 0, we can branch if not 0, we can branch on an overflow or no overflow, branch on negative or not negative, branch on carry or no carry. And the datasheet specs out what all of those things mean. You can also look in the original datasheet and you can see what the actual bits of the status register are, but they don't really matter to us on this processor because we have these different opcodes for saying branch if 0, branch if not negative, and so on and so forth. So that's going to be our main way to specify that we want to do something conditionally based on the result of some prior operation. And exactly which instructions affect which bits in the status register, well, you can see that in this column over here, status affected. For example, increment file or decrement file register affects C, D, C, Z, overflow, and negative. Right? It affects all 5 of those bits. But some of these other instructions, like move file register, only affects the 0 bit and the negative bit. Move WF doesn't affect any status bits. So if you're trying to branch based on the result of some operation, you got to look at your operation in this table and make sure it actually updates the status bits that you're going to try to branch on. So there's some homework questions related to that also. All right, one instruction worth pointing out, the move file instruction, move F, updates the 0 bit and the N bit. And remember, move file takes a destination bit, so it's perfectly legal to say the following. Move file, I don't know, let's just call our variable count. If we say comma 0, it moves count to the W register, but if we just say move F count without anything after it, it really takes the value of count and it reads it and then it writes it back into the variable count. It seems like it doesn't do anything, but it also updates status bits. So we can do this and then we can say branch if 0 to some label count is 0, for example, right? So this doesn't change anything. It doesn't change the value of count. It doesn't change the value of the W register. It doesn't move anything anywhere that it's not already present. But it sets the Z bit accordingly based on whether the value of count is 0 or not. So we can now say as next instruction branch if 0 over here. And this basically lets us do a decision block that says is count equal to 0. And if it is, then we come down to count as 0. And if it's not, then we just come down to whatever the next instruction is after the conditional branch. All right, so that's the story with conditional branching. The other thing I want to talk about is skip instructions. And skip instructions are a different way to do conditional branching. It's a very specific mechanism, and I actually don't suggest spending too much time with it right now. I'd rather you work with conditional branches, branch if 0, branch if not 0. But you're going to encounter these. So for example, decrement file register comes in 2 other versions, decrement file register and skip if 0, decrement file register and skip if not 0. So a skip is like a very short branch. It's a branch basically one instruction forward. So here's the way we could use this decrement file register count. Just subtracts 1 from count and then it goes on to the next instruction. But if we say decrement file register and skip if 0 count, it subtracts 1 from count, writes the result back into count, and then it checks the 0 bit. And if the 0 bit is true, then it skips 1 instruction. And it comes down to the instruction after that, right? Otherwise, do the next instruction, whatever that is. So this is like decrement file register count, and then branch if 0, 1 instruction forward. So let me show you exactly what this looks like. This looks like decrement file register count, branch if 0, skip next, and then there's a next instruction, and then there's skip next. And then we go on with instructions after that. So we subtract 1 from count. If the result was 0, it will skip over this instruction and come down 2 instructions later. If the result is not 0, it doesn't do this conditional branch. It goes ahead and does the next instruction and the next instruction and so on. That's exactly what a decrement file and skip if 0 will do. All right, so that's all we need to say about conditional branches for now. So next time we will talk about bit set and bit clear instructions, and then we'll move on to some more complex machinery.